Am I audible, sir? Am I audible, sir?
Yes, I am audible.
Yes, sir. Yes, sir.
Yes. Well, let me start. Basic introduce yourself. Today is mock final one.
Yes, sir. My name is Vishwarup Saha. I'm from Shantipur, Nadia, West Bengal. I completed my secondary and higher secondary education from Shantipur Municipal High School with 94% and 88% respectively. Then I completed my BSc in Chemistry honors from University of Kalyani and qualified the JAM with the year 26. Then I uh, completed my master's from Indian Institute of Science with 9.0 CGPA and also qualified the CSER NET year 22 and I get 1%.
Yes. Okay, next move on your hobbies. Playing cricket. Yes, can you explain? Playing cricket.
Yeah, the cricket is a group. It's a group playing group match. For the each team contain the 11 player. At the same time, one team used to bowl, another team to bowl, and there is different format of the cricket. T20, one day. And I personally enjoyed the one day cricket match.
Yes, what is the difference between T20, ODI, and Test?
So
What
they
the
are different in the only overs because there is 20 overs and one day it's a 50 and cricket is generally spent for the 5 days.
yes? When did you start cricket? What the meaning of cricket?
The cricket is just it's just a group game which is originated from the England in 19th century, sir.
Yes. What's your opinion about IPL?
Yeah, it's IPL is a very much good initiative to promote the domestic cricket as well as the put good players to pick up the good players from the different states for the Indian team, and also it's a one type of the because of these huge franchises, BCCI earns lots of money, and that can helps to improve the cricket infrastructure for the country in the country. So it's a very good
But
initiative,
अभी
sir.
more clear होंगे. तो कैसा रहा? Yes, I'm audible.
Yes, sir. Yes, sir.
Yes, your native place, district
So
and
my native,
age.
yes, my native. I'm from the Shantipur Nadia districts in West Bengal. So it's a very much popular touristic place with lots of uh, Lord Krishna's mandirs here, and also it's very much famous for handicrafts. And it is quite nearest to the at a distance of 90 kilometers from the Kolkata. So this is I am very much proud to from this place.
Yes, laboratory section. What is lab?
The laboratories are generally got the experimental we generally perform the experimental techniques whatever the theory that we have no we have achieved from the theoretical perspective in the chemistry we generally apply those theory and examines what are the outcome of these results, how the characters, how to handle the reaction. So it basically help us to apply our concepts into the real world. And this also help in the handling of the various chemicals, perform very much reactions, and it's a very much it's me to enhance our skills, and we can further pursue in the research using this skill. So this is the main advantage of the cell lab.
What is elemental analysis?
In the elemental analysis, if we generally analyze the elements within the unknown molecules. They are the main elements of the carbon, hydrogen, nitrogen, phosphorus, and the halogens through the different tests. Well, in the qualitative way. So,
Functional group. Any example of
uh,
functional group? How to detect
we
label?
can generally if a organic compound, we can generally determine what the functional group is present. Like carbon, if we consider the aldehyde and the ketone, we can simply you know, read this differentiations using the tolerance reagent. Carbohydrate give positive silver mirror test, but the ketone doesn't. If there is a aliphatic and aromatic yet, and that can be easily using that can be easily differentiated using the filling solutions, the filling A solutions or the filling B, and the both solutions decolorize in presence of a aliphatic aldehyde, but aromatic aldehyde doesn't. So in this way, we can generally differentiate between these two sets.
What is qualitative analysis? What the main application of qualitative analysis? Application. Qualitative, quantitative, volumetric, grammatic. Application only.
The qualitative we can generally tell the how much amount of the crystalline water is present. Suppose there is a different quantitative applications, volumetric, gravimetric analysis, all these things. We can quantify the how what is the amount of substance. Suppose if we consider copper sulfate 5H2O, this 5H2O that can be easily analyzed using a gravimetric analysis because with the increase in the temperature, they H2 which is present in the crystals generally got evaporated, and we can generally by varying the temperature where this has happened, because when the mass change happened there is endothermic reactions and then there is a very much less mercury, and we can determine the what is the amount of the similarly for the solutions which are part of the volumetric titrations using for the quantitative purpose.
Yes, any drawback and limitation of laboratory and quantitative analysis?
Quantitative analysis, there is some, it's very much requirement to focus. If you use the colorimetric titrations, the color changes should be the sharp, should be always detectable. With a, if you can't detectable, then it's cause that error. And there is also some yes, because Fe2 plus sometimes the which the ions like Fe2 plus we generally oxidized in the air. So we have to take the special conditions. We have to maintain special conditions to prevent the consequences to quantify the P2 plus ions. very much quantitatively into the solution that can be done by adding the essential to reductions method. And this is the human error. And another improvement, the precautions should be taken to take to make ourselves safe from all the chemicals. So this is the ESR. Lab.
Yes, good.
And the other is
Yeah, next is your MSc project. Yes. What the application
yes,
of your MSc project? Application. Any uses? Explain. 4 5 point.
the main applications my MSc project is entitled the civil synthesis of the citric moderate isotretons towards the inhibiting the persistence. It was found the main motto of this project is that when we take the drugs like vancomycins and others, they cause for the curing of the tuberculosis. They generally decrease the tuberculosis for a certain time, but due to the growth of the persistence, it's again resurgence of this tuberculosis occurs. So our motto is to cure this tuberculosis for the completely. So this growth of the persistent cells can be affected by the vitamin C that is recently proved by the different researcher groups. But the main problem with the vitamin C is its doses is very much high, and so it can't be reliable. So the our motto is to increase the efficiency of this vitamin C by changing different moieties and addressing different biological moieties and their studies on the different mycobacterial moieties.
Any drawback and limitation in your topic?
Yes, there is a because actually there is no theoretical studies is has been done has not been done yet to prove that what is kind of the moiety generally, yeah, and how this drug the vitamin C is binding with the protein. So it is totally based on the trial and run. We have to synthesize or develop the new isotetrons that can prevent the persistent cell code based on the imaginations, and it's very much time taking and very much risky also.
Yes, good. Next, why will you become a BRC scientist? Explain briefly.
The main motto of the BRC is the atom spontaneation of the year, and I am very much inspired by. I want to do research in the nuclear chemistry, nuclear medicines for the development of the new isotopes for curing the cancers and all these things. So the BRC I think is seems to be the ideal place for me to be. And other than as a scientific officer, I will try to always improve the research quality by developing the different novel innovations.
What the role of scientific assistant in BRC?
Scientific assistant, the main role of the scientific assistant is assisting the senior scientist in performing reactions and different experimental facts to do the research, to continue to execute the research, and also help in the sorry, help in the pharmaceuticals, yeah, sir, radio pharmaceuticals, development of the radio connections, what is the amount of the radioisotopes used per day. They are all this data accordance is the main mode of the scientific assistant.
What is scientist? What the major responsibility of scientists in our country?
The main responsibility is the scientist to move the frontiers of our science and technology more forward and making the India is competitive because science and technology innovations can generate the more a number of patents and makes our life they get through the new inventions. And these inventions is both economically and socio-economically both are important because through the inventions we can develop different products and that have preference applications. So scientists is perform the crucial role in the development of a country, sir, through new innovations.
Uh,
Yes, sir.
yes, if you will be selected in BRC, how do you feel after 10 to 15 years? What will you change in your department, your system in BRC?
The first I will acquire knowledge about the nuclear chemistry and the nuclear physics, whatever that I didn't know. Then based on the knowledge, I will try to find what is the can be done using this concept and how this problem, different problems can be solved through the different project. I will design the project and try to execute this project as with my endeavors. So this in this way, I want to contribute this upcoming the 15 days through continuous innovations and by giving my full effort. So this is how I will approach for the upcoming 15 years if I will get selected.
Next, suppose if you will be selected in BRC, so what are the main major challenges will you face in during life? How will you manage them?
The main problem that one faces in that because that is it's a research institution, so I have to spend more maximum of the time in the lab, and there is no restrictions in particular because there should be some failure and the success also there. So there is more, both the mix of the day. So I will manage these things by convincing my family members and spending some personal more sufficient personal time with the family. Though it is a less, but as much as I can, I spend my time with the family. And this is how I manage myself. So,
Yeah, next move on your chemistry topics. Yes. Physical
yes,
spectroscopy. Yes. First of
yes, sir.
all, rotational spectra. What the main application of rotational spectra in spectroscopy? Application.
The main applications of the rotational spectroscopy, there is two because the rotational spectroscopy is very much sharp and their positions can be determined with a very much high accuracy. So this can be used for the determinations of the bond length within the molecules, and another applications is finding the important molecules in the interstellar states, and the real life applications is generally used in the microwave cooking because the compound our foods contain the H2 and due to the rotations it generally generate the heat. So these are the applications of the microspectroscopy.
Yeah, rotational source of rotational.
The source of the rotational is as a Kyle storm.
Electron. Yes.
Yes,
Yeah. How to determine the rotational is Jmax value? What the relation
the
between
Gmax,
Jmax and population ratio?
yes, at Gmax equals to root chemical root KT by 2 BAC minus half. So this is the side expressions for this. Jmax equals to root KT by decimals, and the populations can be written as Nj by N0 into 2J plus 1 e to the power minus BAC into J plus 1 into J by KT. So this is the side expression for the population. Yes, sir.
Yes. What the relation between population ratio and Gmax?
So this is the nj by aj 2j plus 1 into e to the power minus BAC. So these ones are the below. And Jmax can be written as equals to root kt by 2 BAC minus half, sir. This is the above equation for the Jmax, sir.
Yes. What the selection rule of rotational spectra? Now how to determine selection rule?
So there is a mu ij. So the selection rules is depend on the can be taken from the transition moment integral, and the transition moment integral can be written as mu I psi I equals to mu cap into psi j d tau. So this is the mu ij equals to, yes, this is the transition moment integral, and if we solve that, it comes out that del j equals to plus minus 1 is the selection rule, sir, for the rotational. So
Yes. What is rotational constant? Rotational constant. What the meaning of rotational constant in rotational spectra? Explain briefly.
the rotational constant is the it's a characteristic, and the difference between the each of line is given by the 2b, and from this rotational constant as a different application we can calculate the bond length, and also through the isotopic substitution we can calculate different abundance of the isotopes, and it can be written as h by 8 pi square rc, h by 8 pi square ic centimeter inverse, where the I is the moment of inertia, that can be written as I equals to mu over the r square. So the expression, sir, this one. So this is the expression. B equals to h by 8 pi square IC.
Yes. Good. What the relative intensity of rotational spectral lines?
The relative intensity is can be written as a relative intensity. So sort of 2j plus 1 into to the power minus BAC into j plus 1 into j by kt. So intensity equals to, so j. So this kind of cartesian very often if you plot the relative intensity versus the quantum number, rotational quantum. This is the card.
Yes. Boltzmann distribution law. Any
Yes,
relation
sir.
between, yes, any relation between relative intensity of rotational spectral line and Boltzmann distribution law. Any
Yes,
relation?
sir. So relative intensities are this one side. We can 2j plus 1 proportional to 2j plus 1 into the power minus BAC into j plus 1 by kt. So this one. This expression.
Yes, good. How to determine rotational energy levels?
The rotational energy level, the energy for the rotational energy level equals to B into J into J plus 1. And if we draw that J equals to 0, J equals to 2B, and the rotational energy gap increases with the increase of the rotational quantum number. So 6B, here the 12B, and there is about 20B. So this is the way we can explain. So this is the so this is the sir.
Yes, yes, good. Yes, what the main application of molecule microwave spectra of diameter molecules? Main application and uses.
What is, sir? What is the main application of?
Microwave spectra of diatomic molecule.
Yes, sir, the main applications can be written as in case of a diatomic molecules, the selection rule equals to A, and the energy difference between the two, each of the positions of the it's given by the 2B into J plus 1, and the J value is equals to 0. So first line is according to 2B, the second line according to yes, and from the distance which are 2B, and from this 2B we can calculate the bond length of the molecule. So H by 8 pi square IC. And further, if we consider, sir, consider the vibrations, like the bond is not rigid. That is because when the rotations take place, there should occurring at centrifugal forces that tends to apart the molecules, and we can consider the bond is not rigid, rather it changes with the bond, and it can be written as, and if we consider that during so the bond is stretching and the compressing periodically, so that should possess some vibrational energy, and as a result we can consider the non and if we consider the vibration is simple harmonic, then it can be written as B into J plus 1 minus D J square into J plus 1 whole square, where the T is the constant centrifugal distortion constant and equal by the 4B cube by omega square. And if you consider that under these conditions, then 2B into J plus 1 minus 4D into J plus 1 whole cube. So this is the side expression. So this is the side expression. The first one is corresponding to the simple harmonic, and the second one comes for the yes.
Here is the what is the meaning of J? What the uses of J and what constant both?
So J, from this J max value, we can calculate the maximum power intensity. So at which the J max value, the maximum intensity of transition is take place, sir. And at D is the centrifugal the distortion constant.
Yes, what is the difference between microwave spectra of a rigid and non-rigid rotator in
The
rotation?
non-rigid is that if you consider the expression of the for those the rigid and not rigid is the same, but with the increase of the at a higher rotational level, the molecule possesses the sufficient vibrational energy so that can return. So the energy difference between the energy level is decreasing. So I am showing that. So this is the graph for the U. So it is same for the rigid rotator, but slightly decreases with the increase of the at upper rotational level. So this is the cell rigid with 2B, 4B, 6B, 8B, 10B, and this is the cell expression. So first one is the cell rigid one. The gap is same, that is the 2B. Here is the expression is same, but at the higher rotational level, the vibration energy is sufficient to apart, and it has a sufficient centrifugal force to make the two atoms apart. As a result, the bond length is the high, and we know that B proportional to 1 by mu r square. So the B will be the less, and so that the energy difference is decreases at the higher level. So this is the below one that you can see the line become for the non-rigid become the more closer side.
Which one is allowed and forbidden transitions?
Those that generally follow the selection rule del J equals to plus minus 1. So these are the say, allowed conditions. Like 0 to 1, 1 to 2, these conditions are allowed, but 0 to 2, these are not allowed.
Yes, both constant energy level is gap is 2B or 4B.
The 2V.
Why? What the reason?
Yes, sir, I'm drawing the energy level, then we can consider. So here is the called the 0V. 4V is possible, like 2V, multiple of 2V. The energy gap should like here you can see. So here in the diagram, in this diagram, so this is a 0V. So here's a 2V gap, first rotational level. Then
Yes,
second
0
will be
to
the
yes.
2V to 6. So the it should be the 4V, like 2B, 4B, 6B, this like multiple of 2V. And their difference between the two line in the rotational spectra should be 2.
Yes, good. Yes, we how many factor affecting in a rigid and non-rigid rotators?
How many factors? Yes, sir. The main factor is the vibrations. So at a upper rotational level, it has sufficient energy to centrifugal forces operating to move the atoms apart from each other. So we can consider, if we consider ball is the elastic, so it's stretching and the compressing with the periodically. So it should possess some vibrational energy. And if we consider the vibrational energy is harmonic, then this rotational energy expressions can be written as b into j into j plus 1 minus d into j square by j plus 1 whole square. So this is the expression for this one. So that has indicated.
Yes. Any drawback and limitation of rotational spectra?
The main drawbacks is the rotational spectra is that it's only applicable the molecules who have dipole moment like is permanent dipole moment that can be only analyzed using the rotational spectra, and other molecules can't be analyzed. And you consider that the bond length for the if we consider the here actually we consider for the determination of bond length that the vibrations is harmonic, but in the real case it is more harsh because the more maximum vibrations is the anharmonic, so it doesn't give the accurate value of the bond length of the molecules. So it is not quantitative, it's not a good quantitative. So these are the some merit to drop.
Yes, what is centrifugal constant? What the application of centrifugal constant in rotational?
So the rotational constant d equals to 4b cube by omega square. So d can be calculated if you consider three consecutive lines, because it's a three root. So it's a three root. So this if you consider, then we can calculate the omega and 4b cube by d, and this omega square can, we know that we can calculate the force constant, that is the 4 pi square omega square c square mu. So these are the expressions, 4 pi square omega square c square. So we can calculate the force constant of that. Is it visible? This one?
Yes, good. Yes, next other is what the main application of polyatomic molecules in rotational? Explain 4 5 point only. Application, limitation, and drawback.
The polyatomic molecules, if we consider the linear molecules like OCS, we can determine the moment of inertia from these molecules, because the polyatomic linear molecules with geometry is the same. So whatever applicable for the linear diatomic molecules, the polyatomic molecules we can use. And it should be that the polyatomic should be that have permanent dipole moment. Otherwise, like the molecule like CH4, this type of molecule can't be analyzed in the microwave spectroscopy. And the calculated bond length from the microwave spectroscopy is far, there is a reasonable amount of discrepancy between these two. So as a result, the decreases for the polyatomic molecules, and the B value is very, very low. So it's very much difficult because they sometimes polarize. So high resolution rotational spectrometer is generally is equal to this. So these are the two.
Yes. Next, what is the beneficial of rotational spectra in our real life, human life, our society? Any 4 5 point?
The fast laser is generally the microspectroscopy widely used in the microwave heating is generally used in the sonar radar system. It is help in the detections of unknown species in the interstellar spaces. And third is that because it's very much sharp and its positions can be determined with a very much high accuracy. So as a result, we can determine the bond length of fine structure, the rotational fine structure, and with the important ideas about the molecules.
Yes, good. Good point. Yes, good. Your first mock is finished. Yes, good work from your side. Next we will discuss is second mock. Yes, try to all cover 1 2 topics. Today only one topic. Yes, no. Rotational spectra.
Yes, yes, sir.
Next day cover all topics. Mostly 3 4 topic. Yes, no. Rotational left topic
Yes,
is vibrational electronic Raman.
yes, sir. Vibration electronic diagram.
Chemical kinetics, pericyclic and coordination. Yes.
Yes, sir.